Hey everybody, we're going to be looking at our Unit 3, Lesson 9 today. And what we have been talking about for a while, and we are going to kind of extend this with something we learned a while ago, um, is that a triangle with all of the same angles is guaranteed to be similar, right? It's not the case for um, shapes with more sides, right? It's not the case with that, but triangles, because there's only three angles, three sides, everything's a little bit more locked down. There's fewer ways to configure the sides of a triangle. Um, that Funny enough, if we know all the angles, we're good. But we also know, which is even nicer, is that because triangles have a total of 180 degrees of interior angles, all we need to do is know two of the angles and we know the third, right? Because if, for instance, I know these two angles, I subtract A, I subtract B, right? There's a certain number that's left over. Give any number for A, give any number for B that makes sense in a triangle, and it's guaranteed that that third angle is set, right? It's not a mystery, right? And so if we can show that two triangles have just two angles equal to each other, the third one has to be locked down. So for instance, we see here angles A and angle D both have the same markings. Angle B and angle E both have the same markings. So this implies that angles C and F need to also be equal, right? If you follow the logic triangle to triangle, then that needs to be true. So we only need two angles. Again, we can sort of see this figure if we think about our dilations, right? If we kind of have the same center, and we're going to have the same angle here. There's one, and as long as we fix another angle, again by looking at our dilation this way, we're going to guarantee that the other two angles are equal as well, right? And so that's sort of the logic. So let's look at some examples real quick of how that can work and how again we can kind of figure out everything from there, right? So common way that a problem may be given to us is that we're given two angles in a problem, and initially you may see, okay, well 40 and 60 are different than 40 and 80, aren't they? Right? Well, they're not the same, so you might be tempted immediately to say, well, these aren't similar triangles. Um, However, though, because of the issue with 180, right? If I were to say, okay, well, what about 180 minus 40 minus 60? What's left? Okay. Well, together this makes 100 degrees. So 180 minus 100 is 80. So that needs to be here, right? Well, this is 80 down here, right? And if we did the same thing, if we did 180 on the bottom minus 80 minus 40, okay, if we did this, this makes 120 together, meaning we would have 60 degrees left. Right, so that's got to be 60. Well, look up here. We've got a 60-degree angle, right? So as long as we can show that two angles are the same, which that work we did at the top, it guarantees that the third angle must also match, right? So we didn't even have to do the calculation below, but I just wanted to show you that that has to be true. And once we know that all of these angles are there, then we can go forward and kind of find missing pieces, right? So again, I can look for, how 3 relates to 5 is the same way that y versus 6, right? So if I could say here, sorry, let me zoom over here. So if I do 3 over 5, right, that would have to be the same as 6 over y, which is going to have to be the same thing as x over 8, right? Like this has to hold if we know. Now, we're not going to solve for these missing pieces here, but again, it's just that ratio has to hold in order for them to be similar. And again, if we know that they're similar by the angles, we can take it from there. So the problems that you're going to look at today are they're asking, do you have enough information to say that two triangles are similar to each other? So there's three options today. There's either A, yes, B, no, or C, we don't know, right? So again, if we know the measure of angles, or if we know that they have the same measure or something like that, we can usually say a yes or no. It's when we're lacking enough information lacking enough implied or given information, then sometimes we can't do it. But if we know two angles, then we know enough, right? So that's the hunt. Do we know two angles? In this problem, we have two angles, right? So this is not a mystery. We're definitely going to be able to figure out whether or not it's a yes or a no. Again, if we look here, we have 78 and 57. So together, this makes 135. So its partner would actually be 45. So that's what we're expecting, right? This is what this angle up here is going to be. It's going to be 45 degrees up here, okay? Now, the reason how I get that is by doing 180 minus 135. So that's 45. So when I look here, up here at this triangle at the top, right, I see I have a 78-degree angle, right? That's a check, right? But the other angle it provides is 47, right? That is not present in either in the other triangle, right? So this is a big no, right? 47 is not 45, 47 is not 57, right? So they can't possibly have all three of the angles the same because I've proven that one of the triangles doesn't have a 47-degree angle. So if it doesn't have it, it doesn't have it. Okay, let's look at another shape, right? So that was a no. So again, we know here based off of just looking at this that we know that we have two angles in each one, so I can find the third, right? So let me do this on the right side. So if I put these two angles together, 52 and 43, this makes 95 degrees, right? If I did 180 minus that, 180 minus that is going to be 85 degrees. Okay, so I know that that's going to be 85. Right? So when I look over at my other triangle, I see I've got 52 on each, and I've got an 85 on each. Right? So because I did my math correctly, that guarantees that this angle up here is 43 degrees, right? It's going to guarantee that number. So this is yes. Like I know for a fact that these are similar, again, because by doing the calculation for my third angle, I can find that it matches the other one. I can find that there's two angles in each, at least that match. The third one has to match. So what if we aren't given numbers, right? So this definitely brings into play this last option, right? So as we get a little bit more complicated, maybe we don't have enough information. One of the tricks when we have sort of composed figures like this, one of the things I recommend doing is kind of separating the two triangles into just separating them into two different ones. So imagine the smaller triangle here. So I'll try and recreate it. Okay. So we'll do that one, right? So we see that. And then we have sort of this larger triangle here that kind of looks like it's in a different orientation, but again, this doesn't mean that it's not similar, right? So again, we can see these two things. Remember, we're not talking about this four-sided figure down here. We're talking about RTV, the big triangle over here, and UTS, right? So how do we deal with this, right? So let's start looking. So I see here in the small triangle, I see down here that we have angle around where angle S is. I'm going to use red here to make it stand out. We've got a known angle here. Okay, so that's where S is. So this is what I was looking at right here. So that's in the small triangle. I also have that in the big triangle as well, angle V. So these two are the same. So now what I need to do is figure out, is there another angle that is the same between them? Okay, so when I look down here, or really, I'll just get straight to the chase. If I look up here, right, angle T is not only a part of the small triangle, but it's also a part of the big triangle too, right? Because it's in the same triangle, right, we can say again, like by that reflexive property, that it is congruent, right? So we know that those angles are going to be the same. So this is, I know two angles, I know two angles. These are similar, right? The third angle must be equal if I know that two other ones are, right? So even though it looks like they're not giving us enough information, because they compose the triangles together, they have a shared angle, and that is that piece that we're missing. Now, we can still also have problems where we just don't have enough information. We're not told any angle here right off the bat that's given to us is the same. We have separate figures, but they're completely separate triangles, right? They don't have a shared angle. Um, we don't even have, again, vertical angles here. Again, that's not a straight line, so we don't have that. Now, that doesn't mean that there's not some information that we know. Okay, that doesn't mean that. When we have what we can see here, sorry, is that we can have parallel lines, and if those parallel lines are cut um, at a at a certain amount, we can see there are some angles that we can say are equal. We can do that, but if we kind of take that to this level, right? This is not inside one of the triangles. We can't really do anything with that. We could probably at most again say that maybe these two angles are equal, right? We have a transversal here. We can see that, but we don't really have enough information otherwise to go from there. We can't compare this angle and this angle because we don't know anything about these lines, right? We just don't have enough. Um, and that can be tough because there's so many different properties in geometry, but really all we can say for certain about these two angles is that these two need to be equal to each other, right? So there's just not enough information to go from there. So when we get to more complicated shapes, obviously that's in play, but as long as we know two angles, especially at the beginning, that's all you need to know, and you could say yes or no.